तीन हो गया।
Good morning to all.
Very
Today
good.
we have one, ma'am, if it will be very good if you kindly make your video
Okay.
available, because then the people will be able to understand quickly,
Very
because
nice.
you know
I'll
what we
start my
express.
video. Okay. I started my video now.
Thank you. Thank you. Thank you. Thank you very much, ma'am. So today we have one very important topic which is related with the water quality standards, and we have with us uh, Miss Shobha Kumar, who has a lot of experience or very good experience from Shri Ram Institute of Industrial Research, Delhi. She is a member, Water Supply and Sanitation Collaborative Council. She is member of Bureau of Indian Standards. She has worked as project in charge for environmental, water, wastewater, sanitation, and water resources. She has strong understanding of quality management system, EMS, and OHSAS 45001. She has training and education in the areas of environmental, analytical, and material sciences, organized large number of training programs. So I hope that this today's session will be very good for understanding the requirement of this water testing, how it can be done, what are the standards, and how we basically in India doing it. What is our the plan, the next plan for the industrial and the technical or the laboratories point of view. We have with us our honorable Shri B.N. Dikshit, Director Sahab, Director Legal Metrology, Government of India. I would like to request Director Sahab to kindly inaugurate this workshop. Please, sir.
Thank you, Ashutosh ji. This is I am getting again privilege to join your conference. I hope that this will be very successful. And you have talked about a lot about Madam Shobha. So she will certainly give the good knowledge, express the good knowledge as required to the peoples who are joining this very seminar. The water testing is very important, and you are getting the lot of water in bottle. And all these things are tested by the BIS, and these things are also being dominated by the FSSAI as well. So, uh, so there is the role of the BIS as well as the FSCI. So, madam has to express also that how to get the certification of these very water testings from both BIS and the FSCI, because the BIS is having the standards and BIS is also certifying this very water testing, and this is claimed by the FSCI, and that is not done by the FSCI. Most of the water is done by the BIS. And so wherever the municipal water and other place water which is supplied to the common peoples and all that very things. So these things are sometimes are being checked by their authorities, but it is not as per standards. So there is a need that all the water supply should be having the a good qualities and which may be equivalent to the BIS standards. I hope that this conference will be very successful and Madam Sova will give the good lecture and everybody will be benefited. Thank you, Astoshi.
Thank you very much, sir, for your kind words. Certainly, we are always obliged from your motivating words, and certainly we are trying our best to do something for the society. Thank you very much, sir. Now, I would like to request Ma'am Shobha Kumar to kindly make a brief understanding or knowledge and the presentation so that our participants can understand what are the requirements of the standard and what are the equipments, how to test, all these things. Over to you, ma'am, please.
Thank you so much, Mr. Ashutosh and Mr. Dixit, for your kind words. I try my level best to be stand up to your expectation. So, a very good morning to all. Today I am going to talk about the quality standard for the safe drinking water. The safe drinking water is not about the national concern, it is a global concern. So, before starting my presentation, I will like to ask or say, I would like to understand why it is so. As, as you already know, as per the United Nations, the sustainable sure, excuse me. As per the United Nations, Sustainable Development Goal 6.1 says that safe and drinking water to and affordable drinking water to be provided all. So with this, all the countries joined their hand with the United States to make the agreement that safe drinking water is a fundamental national right. Now, as you already know, our two-thirds of the earth is covered with the water, and out of which we have only 2.3% for the drinking purpose, that is a fresh water. We have a very limited resources. So with this all limited resources, what we have to do? We have to manage the water properly and avoid as much as unnecessary wastage. So for this, what we can do, as you all know, water is connected every single life on this planet in their day-to-day activities directly or indirectly. So we can say water is very so this indicates water is sustainable. So for the safe drinking water, make the make it our make this a defined civilization. Now, while we are talking about the defined civilization, so we must know what is meant by the safe drinking water. Safe drinking water, it should be free from all the contaminants like physical, chemical, biological, radiological, and the toxic impurities, so that no one should expose to any harmful effect. Like to achieve all this, the national standard, international standard come up to help us to meet the requirement for the safe drinking water. So all the safe drinking water should meet all the requirement in each and every respect to make the people happy and healthy. So to understand this better, let me start with the presentation.
Santosh ji.
Yes, sir.
If ma'am is not able to share, yeah,
No,
okay,
I
it's
will
okay.
share
Thank
it.
you.
Just give me a second. Just give me a second.
Ma'am, perfectly, ma'am.
No problem, ma'am. Ma'am, you take your own time. No problem, please.
Now, my topic of today's presentation is water quality standard for the safe drinking water. So I have already said a lot about why we need the safe drinking water. So let's begin it with, as you already know, water is an essential component for the survival, as water is very precious. As water is very precious. Why water is very precious? Because it is vital for the life. And the water is a very natural and the healthy drinks which make our mind and body active. Again, I must like to say our body is also made up of over 70% of water. So if we get a proper and safe water, then our body will work properly. So this the precious water make our earth is unique. Now, water quality is deteriorating. As we already know, there is a lot of things going on in the water quality as lot of industries coming up which throw their waste in the river and lake, which make it polluted. All the pesticides, all the waste, all the hazardous material, all the garbage. That make the fresh water deteriorating. Quality of the fresh water is deteriorating. Now, because of this, the freshwater resources are depleting rapidly. Naturally, when we're doing so much nuisance to the water, so this is going to be depleting rapidly. What? Why? The basically every human activity make the fresh water depleting because we are not doing any effort to recharge it. Only we are doing depleting it. How? First, growing of the population. As the population growing day by day, it's make the water demand of the waters get increased. Again, I have already said that we have a limited resources. So have to be used judicially. Second, the deforestation. Deforestation means we are cutting the jungles, tree to make the land for the people. By cutting the tree, what is happening? The land is less and soil erosion is taking place. It's not able to hold the water to go in the groundwater. Third, pollution, as all I have already described it. And thirdly, we are not storing the water properly. Storing the water properly means we are not doing any rain harvesting. It's a very less. It is there, but not in a proper demand. We should harvest the rain that recharge our water resources. So what we can say in nutshell, water quality plays prominent role in water management. Why? What is the water quality criteria? Water quality criteria we need it for the drinking water quality, for the packaged water, and for the natural mineral water. While packaged or natural mineral water coming up in the market, as it is going to be growing industry because the safe drinking water quality is getting depleted. Why we need all this water quality? It helps us in interpreting of the water quality data, and by interpreting that data, we can remediate it. It's a type, what type of water is this, how can we be used, what is the feasibility can be done, and how much is the effect. Now, let's start it with the general physical parameter of the water. General physical parameter of the water consists of color, odor, taste, turbidity, dissolved solids, and the pH. I know when we have a glass of water, we see all these things. Our inner conscious mind and our eyes also take this in the consideration. Color is okay, odor is good. We just smell it, the odor is good. While drinking it, the taste should be fine, and turbidity, it should not be turbid, completely transparent. Total dissolved solid that cannot be seen with the naked eye, and the pH that cannot be also. So these are all the important for a parameter for the general physical analysis. Now we'll take this parameter one by one. First we take the color. What is the causes of color in the water? Color of the causes is the major inorganic ions such as iron, copper, chromium, and the manganese. These elements, these ions have come from either from the waste discharged from the different industries, not be properly treated. Also, when we get a water from the iron pipes, it get corrode and it gives all this ions in our water. Second, humus and peat material. Humus and peat material are the organic decaying material. So humus is decayed very fast, which impart the color in the water, and the peat is slow, but it also impart the color. Thirdly, plankton and the weeds. Plankton and the weeds, they just grow in the fresh water, even sometime in our pipelines also. So that has to be properly cleaned. Otherwise, they will all impart the color. These are the main causes of the color in water. How we observe the color? We observe the color by the two different things. First is the apparent color. That is without filtration. What is it that just I dip the glass in the lake or river and see it, wow, how is the water color? It gives me color obvious there because it's not very clear. Second is the true color. True color is very easy to measure. We first filter the water. While what will be happen when we filter the water? While filtration the water, it remove the unnecessary contamination like the leaves, like the sand, like the mud. This can be removed from the water and it make the water quite clear. So what is the measurement? How we measure this? There are the two methods to measure the color in the water. First is the visual comparison. Visual comparison is very easy. We compare the water with the standard after filtration because we measure only true color. We make the standard, different standard. The standard can be made by mixing the chemical. We can do it in our laboratory very easily. There's no problem. And second is the spectrophotometric method. Spectrophotometric method. Spectrophotometric method is used for the have a different type of a color in water. That is, you can say yellow color, blue color. Sometimes it gives the green color. Sometimes red color also. That is basically for the industrial water. Now, the second one is odor and taste. Odor and taste is very important one for drinking water. What is cause? Natural resources, natural sources. Naturally, when so many things fall in the river, on the lakes, it gives the odor and taste in that. And the second, the microbiological activity which already come in the water. It is automatically going in the water. How to observe this? We observe this as by smelling it. For the odor, we can smell it. How to smell it? We just take a water and put our nose near to it, then see how it smells, good, bad, or whatever. Whatever the odor you feel it, you can describe this. But in the technical, it will be used as the agreeable or the disagreeable. Same with the taste. Taste. Taste, for the taste, you need not to be drink full glass of a water or to gulp the sip of the water. You will just put your tongue near the water and you will get a taste. Taste can be sour, salty, bad, any kind of thing. If doesn't taste anything, then you say the taste is agreeable, and it's not, then it is a disagreeable. The measurement of the color, odor and the taste cannot be determined in the absolute unit. It can be done by visually or by doing yourself. Now the turbidity. Turbidity also very important part of the water. Turbidity, what is the cause of the turbidity? Turbidity is a reduction of transparency due to the presence of what? Silt, clay. Naturally, it is there in the water, natural water. And by the finely divided organic and inorganic material. That cannot be stopped. It can only be removed by the treatment. And lastly, plankton and the other microscopic organisms. This microscopic and plankton is not able to easily visible from the eyes. It has to be done under the microscopic testing, or it can be done with the proper method. Well, here I would like to say, if somebody give me the glass of water which has not clear at all, so I will say, no, I'm not going to drink that water. I think same happened with everyone. No one is going to drink that turbid water. So it's better we should have a clear and transparent water. How it is observed? It is observed in the nephrometric turbidity unit. That can be done by the using turbidity meter. Now dissolved solid. Dissolved solid not easily visible from the eyes. The definition of this dissolved solid is residue remain in the weighed dish after passing through the GFC or the Whatman filter paper having the pore size 1.2 micron, and we should dry to a constant mass. We have a two different temperature for the constant mass, 105 plus minus 1 and 180 plus minus 2. 105 is used for the, you can say, the soft water, which have a low conductivity, low solid, and the 180 for the high solids water. So dissolved solid you can also observe. आप लोग भी तो घर में पानी कभी कभी बॉईल करते ही होंगे ना. जब आप पानी बॉईल करने के बाद उसको ठंडा होने के लिए रखते हैं तो क्या देखते हैं, एक लेयर वाइट लेयर डिपॉजिट हो जाती है. That is called an residue, dissolved solid. It is there in the water which we cannot able to see through our eyes. But when we boil it and again cool it, then we see it, the layer of a white precipitate is formed. The measurement of this solid is done by the gravimetric analysis. What is its impact? Due to the high TDS, plateability decreases. Naturally, plateability will be decreased. We won't be able to increase the drink it, and it may cause gastrointestinal irritation. So, have you seen this? Dissolved solid is such a major important factor of the physical parameter. Now, next is the pH value. pH. Yeah, I know. pH is just come with the taste. What is the pH? The definition of the pH is reciprocal of the hydrogen ion activity, and it will be denoted as negative logarithm of hydrogen ion. How it will be done? It will be measured by the two methods, that is by the pH meter. That is a very easy and correct instrument. What we do in the pH meter, we calibrate with the standard buffer to make it to give the standard pH, and we basically use 4, 7 or 10 pH. As you already know, the drinking water has a normal 7 pH, which is for which we can able to drink it. And second, the conventional method by the color indicator method. It is also there because sometimes we don't have a pH meter working properly. We don't have any other alternate. Then what to do? Then we can easily go with the color indicator method, as it is give the red to orange color in the acidic medium, rather for 3 to 5, and 6 to 7 it is slightly yellow or greenish, which is a perfect pH for drinking. Now from the 8 onwards to the 11, it gives greenish blue to the violet. So what we can say in nutshell, what is the acidic pH? Acidic pH is less than 6.5. That is lead the corrosion in the pipe and also sour taste to our tongue. Whereas alkaline pH, that is the more than 8.5, it gives scaling and the bitter taste. So what is the prescribed limit for the pH? Prescribed limit for the pH as per standard is 6.5 to 8.5. That will do no harm to our body. Now, come to the general chemical parameter. General chemical parameter include chemical and magnesium, total alkalinity, chloride, sulfate, fluoride, nitrate and nitrite, cyanide, sulfide, phenolic substance, bendel oil, anionic detergent, sodium and borate. These are very essential components. It has to be present in the water, but in the limited quantity, as they should not harm to our body. So let's take each and every parameter one by one. Now first we'll go for the calcium and the magnesium. Now let me tell you about the significance of the calcium and magnesium. Calcium and magnesium are the major constituents for the human beings. You know this thing, when we're getting old, we used to go for the testing of this calcium and magnesium in our body. Because if it is below the limit, it's really going to harm to our body. Calcium, as you already know, is very necessary from the bones. It was well said, oh, you should drink a milk, you should have a cheese, you should have a eggs, so that we will give you proper amount of the calcium in your body to make your bones strong. And the magnesium is very essential for the red blood cell. Even if you got a less magnesium in your body, it will really affect to your health. That will make you a very, very ill, and sometimes the deficiency of the magnesium cannot be treated properly. Now the measurement. How we can able to measure the calcium and magnesium in our water? We can't by dipping the finger measure this is calcium, this is the magnesium. No, no, no. This is done by the two methods. First by the instrument using the atomic absorption spectrophotometer. In this we put a standard, prescribed standards to know that our instrument works properly. It should give a straight line. Then we put our standard in the instrument and it will give the correct reading of the calcium. And second, by the volumetric analysis, this can be easily done in the laboratory by any of the analysts. In this, what we do? We'll make the EDTA solution, we'll make the indicators, we make the buffer. I think a lot of the people which are working in the laboratory, they must be knowing how to carry out the calcium and magnesium analysis by the volumetric method. So high concentration of calcium and can cause excess deposition in the bone. Yeah, here I would like to say one thing. We should not take a calcium in too much amount. It will deposit in the bone. It won't go from the bone. It will make our bone not working properly. So everything should be taken in the prescribed amount, in the known quantity, not as much, yeah, le lo, yeah, calcium is good for the health. No, no, nothing like that. And whereas magnesium concentration, where the concentration of the high concentration of the magnesium causes a diuretic effect. The diuretic effect means then you're going to take out your water through the urine and through the sweat, which take out your minerals from the body and make you slow down. It will also affect on your memory, and there's so many effects. So I hope you can understand both calcium and magnesium are the major constituent for our body, that is for the human being. So to be taken in the proper and the prescribed amount. Now, total alkalinity. It is also one of the very important components. How we define the alkalinity, total alkalinity. It is known as, it is tell us quantitative capacity to react with a strong acid. But when we react the water with a strong acid, then we come to know, or in other words, we can also say the acid utilization capacity of the water. As you already know, water is neutral. It has a H plus as well as OH minus ions in it. Well, when it is in the proper amount, it is neutralized. But you never know when the acidic concentration get increased, how you come to know? This can be analyzed only by the analysis. So how we measure it? We measure the total alkalinity by the two methods. First by the instrumental, by the potentiometric method, and second by the indicator method. That indicator method also the volumetric analysis, in which we add the proper indicator and we titrate with the acid, a very light acid, so a light acid, not a very strong acid. So it is very necessary, and when the indicator change the color, then we come to know this is our alkalinity. What will be the effect of the alkalinity? If taste of the water became unpleasant with the higher concentration. In our coming slide, I will like to tell you every parameter have a prescribed limit. If they exceed with the limit, then it will definitely go to affect on our health. Now the chloride. chloride also. Chloride we are also taking in our food also. The definition of the chloride is major inorganic ion present in the water which contribute to the taste. Naturally, I can't drink that salty water. If I am able, or you all may be able to drink the salty water, then why can't we use the sea water? We have a plenty of sea water, but no, we cannot drink the salty water, that is which contribute to our taste and which make our taste very bitter. How to measure the chloride? Chloride can be made by the two methods, by the azimuthal titration and by the colorimetric method. Colorimetric method is carried over the low concentration of the chloride because sometimes, as in we can say in the distilled water, in the millipore water, we have to measure the chloride in a very low concentration. That cannot be measured with the azimuthal titration. The azimuthal titration is done by the silver nitrate using the potassium chlorate indicator. I think most of the one you are aware of it. Well, if it is beyond the permissible limit, what is the permissible limit? I am going to tell you in my preceding slides. The taste becomes salty, and I said now salty water cannot be drink. If somehow a human can able to drink the salty water, then the drinking water problem gets solved. But it is not now. Now, next important parameter is sulfate. What is the occurrence of sulfate? Sulfate occurs naturally in the water that we cannot stop. It occurs naturally in the water. Only by the treatment, by doing the some treatment, some method, we can low down the concentration of a sulfate. It forms in the water from a few ppm to the 1000 ppm. We have a lot of hot spring containing a lot of sulfate in it. So it is not a joke, we can say, to have a sulfate as a natural in the water. I think there is one hot spring of the in the Sonipat or maybe in the Sona, in which the people think that it's contained, it will remove your this problem, that problem, but I don't think. I think scientists never agree to that. And we are the scientists. We have to go by everything in the experimental way. Now, how to measure the sulfate? Sulfate is measured by the gravimetric analysis and by the turbidity method. In these two methods, what we do? We precipitate with the barium chloride. Gravimetric, we precipitate with the barium chloride in a high concentration, if it is present in high concentration, more than 40 ppm in the water. Then we have to precipitate it, we have to filter it, and we have to ignite it, and then we have to weigh it. The precipitation is formed as a barium sulfate, and with the help of the calculation, we can come to know the amount of the sulfate present in the water. Second method, turbidity method. Turbidity method will also use the barium chloride, gelatin. When we add the gelatin having the barium chloride in it, then what happens? The precipitate is formed, it's remained in the suspended form. When it is in a suspended form, it's make it to turbid and it won't settle down, and we can read in the on the UV with having the prescribed wavelength. I think it is not a difficult thing to analyze the thing, but we need a proper precision to carry out this experiment because it's a question of a life and death to the person. So high concentration can cause the gastrointestinal disorder. It is increasing day by day, as you know it very well. Next is fluoride. Fluoride is a very essential and an important component of the water. How it is? It has occurred. Basically, fluoride occurs naturally in the water, or from where it has come naturally, from the rocks only, because our water is coming from passing through the rocks. When this water comes from the rocks, it strikes to the rock, and when it's continuously striking to the rock, the rock gets dissolved with some of the ions in it. And fluoride is a water soluble compound, or we if we are preparing some packaged mineral water, if it is not there in it, then we can have to add it in a controlled amount using the proper method. Now, here we have a how to measure. Now we have to measure now. If the sulfate is there, if the fluoride is in the proper quantity in the prescribed limit or not. So there are the two methods for measuring the fluoride in the water. First, the instrumental by the selective ion meter. Nowadays, we go mostly by the instrumental method. That is very nice also. It is less time consuming and the more accurate. And it also like you can say if you have some suspended impurity, some color is there in the water, you can easily measure it with the selective ion meter. Now, second, by the colorimetric method. This is a conventional method and very good and accurate method. But this method has a limitation of measuring the fluoride in 1.5 ppm in it. And also a lot of color water cannot be measured by the colorimetric method. Naturally, it gives the color when we add the reagent to in it. And we add the reagent, it gives the color, and we have to read this color on the UV spectrophotometer at the prescribed wavelength. So both are method are accurate and easy, but better to go for the selective ion meter that will give you more accurate result on removing all the interferences in it. Now, what will be happen if the fluoride is increased in our water and we are not able to know beyond the permissible limit? Fluoride causes the dental skeleton that's called the fluorosis. Everybody must be aware that Rajasthan contain a lot of fluoride in the water. I know, I think. And have you seen the teeth of that the people living there? They have a yellow teeth sometimes. They have some red dot also on it. And their teeth are decaying very fast. That is also, these are the question of the teeth, not only the question of teeth. It is also of the bones. Our skeleton bones, our every bones will also getting deteriorate by consuming the high amount of the fluoride. So I think I make you understand the fluoride is a very important and essential element to analyze in the water with the proper method and with all accuracy. This is I'm telling you continuously by because you have to do the analysis very accurately and all parameter has to be taken care and not oh let's do the fluoride only. It is a every parameter contribute to your health if it is increased in the prescribed limit. Let's go the next. Nitrate and nitrite. Again, nitrate and nitrite is also a very important component of the water and very essential to our body. But again, I must say, in the limited amount. How the nitrate and nitrate occur? Because we have a ammonia in our water, it's come in any form, in the sewage or anything for the industrial pollution. When the oxidation, naturally we have a oxygen everywhere, so it gets react with the nitrogen and the oxidation is carrying out. Ammonia is a very dangerous form. It gives the it gives the water is polluted. But when it gets oxidized in the form of nitrate and nitrite, which is an inorganic form, it get a better quality in that. Better quality to drink because it is also essential as it is also essential parameter because our body needs all the minerals. Not we can say, yeah, remove all this, remove all this. No, we can't remove everything. We need every element in our water that is necessary for our body. Now, how to measure? Also, we have a different method for the nitrate and the nitrate. Halaki, when you read the specification or the method analysis, then you will come to know. Nitrate can be easily analyzed from the nitrate. What are the methods for the analyzing of the nitrate? Naturalization method first, that is again a colorimetric method. You have to distill the sample because sometimes all impurities can be there which can give the color with the natural reagent. So You have to distill the water, and then you have to add the natural reagent, and you can read on the UV. Again, it can be carried out in the low method, low amount. When sometimes the nitrate can be high in the water, then what to do? In the higher quantity of the nitrate, we have to go for the titration. The method is the same. First, have to distill the water, then we have to titrate again in acid and nitrite. Nitrate can be measured by taking directly the sample, water sample, or it can be done by the distillate amount of the distillate from the distillate what we had done it from the nitrate. We can take a small amount of the distillate and we carry it out the colorimetric analysis of the nitrate. Excess of nitrate and nitrite, what will be happen if the excess of nitrate and nitrite cause the blue baby syndrome? Yeah, it is a very, you can say, fatal disease. If it is increased in the body, then anything can be happen. But sometimes you have seen when the baby is born, it is blue. It is blue because of the excess of nitrate in it. I would like to say, yeah, Mr. Murthy has raised his hand for this, like nitrate is not essential. I know it is not very essential. I agree to that, but it is an important also. Now we also need a bit nitrate in our body. I hope you agree with that. Next is a cyanide. Cyanide. You must be laughing. Why cyanide? How the cyanide come in the water? Yes, it can occur. Occurrence of the cyanide in the water make it highly poison. It is a highly poisonous radical combined with the sodium and potassium to form the NaCN or the Kc. When it's combined with the water, because water is also having the sodium and potassium in it. So if it is there in a high amount, if we combine with the sodium and potassium, it make it a poisonous component like sodium cyanide and potassium cyanide. As such, the fresh water or the, we can say, the natural water, they don't contain the cyanide in it. But nowadays, the water quality is getting deteriorating as everyone, because of the industrial pollution, they are sometimes not treating their waste properly, and they just throw their waste, discharge their waste as such without treating it. So if it is contains cyanide, it will naturally come within the water automatically. Because if we had to come to know that it is cyanide in it, then the proper treatment can be carried out. Measurement of cyanide can be done by the selective ion meter and by the colorimetric method. Again, these are the very good method for analyzing the cyanide in it. And what cyanide do? If the cyanide is present in the water, it causes the toxicity, which is a very factor. Next is sulfide. These parameters nowadays are including in the quality standard to make the water very safe for the drinking purpose. Again, what is the occurrence of the sulfide? Sulfide is present in the form of H2S. Sulfide occurs in the groundwater, especially in a hot spring. Because our hot springs contain so many elements in it. So that has to be taken care. Measurement is carried out by the hydrometric, by the colorimetric method. What would happen? Water become toxic and cause the odor nuisance if sulfide are present. Naturally, if sulfide are present, it causes the odor nuisance. Water became toxic and cause the odor nuisance. Odor will be nuisance. You won't be like the odor of the water, and if sulfide is present. Next, sodium. Again, I am telling you, sodium is also very important. But again, I will say this. It should be in the prescribed limit, not in excess quantity. Significant. It attributes to our major cell functions like the digestive system, sensory function, and the cardiovascular system. So now you can see now it is a very important element of our water as well as for our body. It is measured by the instrument method using atomic absorption and the flame photometer. There is one conventional gravimetric method is also available, but that a very lengthy lethargic method that takes a lot of time, and sometimes the proper estimation cannot be carried out. So it's better to go for the instrumental analysis. What will be happen if the sodium is high? Beyond the prescribed limit, it can cause a cardiac difficulty in the human being. That can also be fatal. So sodium is as well as necessary and can be dangerous. It's not taken in the proper amount. Prescribed limit to be there, we have to take in that. Another element, that is the organic contaminants, phenol, detergents, and the mineral. They should not be present in the water. But again, what I have said to you, nowadays, water is getting, quality is getting deteriorated. Anything can be present in the water. What is the occurrence of all of this? Phenol are the hydroxic derivative of benzene may occur in the natural water. It can be in natural water also. And detergent enter in by discharge of aqueous solution. Now, we all do a lot of washing in our home. करते ही हैं हम सब. Even on the river, near the ghats, lot of ghats are there. People are used to wash their clothes. What they used to do after washing the clothes, they just dispose their soap solution into the river or lake. That will ultimately go. For our drinking water. Sometimes, if it is in very low quantity, it will be taken care, or sometimes it is not. Then it would give a harmful effect. Mineral oil. Initially, the mineral oil, it is, I don't think, a very important element for the drinking water, but now it is. What it is? What is a mineral oil? Mineral oil is a fatty matter originated from the vegetable. As you all know, the vegetables are all polishing by the oil. While washing the vegetable means they are putting some oil on the vegetable. They are putting some oil on the vegetable to make it shine and glossy. How they can be measured? The measurement can be done of the phenol and detergent by the colorimetric method. It has a very good and proper method to go for the analysis. And the mineral oil is done by the gravimetric as well as the instrumental method. So what will be happen? What will be happen? The presence of the phenol and the mineral oil may cause the observational taste and odor. Naturally, because these are the prime parameters for the drinking water, and detergent cause froth and unacceptable appearance. Obviously, if you're taking the water from the tap and give the food, then what you think of it? Oh, what is coming in the tap? Is the water is not good? It is not a drinking water. So every parameter has its own importance in it. For our safety, for our body safety, and for the safe drinking water. Next, metals. So I must say it's the essential part, because we also need some of the metal in a very, very low quantity in our body. It should not be moved out from the body, and very, very low quantity, though it should not be harmed. All metals are not necessary, but some of them. So the main metals are present in the water or we analyze in the water samples are nickel, copper, chromium, manganese, silver, zinc, antimony, lead, barium, arsenic, cadmium, selenium, and the mercury. Arsenic, selenium, and mercury are the very, very toxic to the human body. Even you can say lead is also there, it is very toxic. So when we go for the highest prescribed limit, then you will observe that they should be in very, very low quantity. And in some cases, they don't have any relaxation limit for the metals. So if it is there and in the prescribed limit, then it is okay. But if it is more than the prescribed limit, then it is not good for anyone. What is the significance of metal? Effect of the metal varies from the beneficial to the dangerously toxic. What I am telling you. They can be beneficial and they can be dangerously toxic, which happen on their concentration in the water. Naturally, I have already told that they should be in a very, very low quantity. If it is going, it is in the ppb level, sometimes it is in the ppb level, and in some metal it's in the ppt level. So very, very less quantity if they are present. If they are not present, then fine. Then the toxic elements like arsenic, selenium, mercury, they need not to be present in the water. How we measure the water? Measurement of the water can be done with using the instrument by atomic absorption, ICP, OES. They measure the water, they measure the metal in the water in a very, very low quantity in ppb level, in the ppbt level also. Again, the second method is by GTA. GTA is also a very good and advanced method to measure the element in the PPT level, PPB level. Because the colorimetric method or any other method doesn't help in to measure the element in the PPB level. As it is present in the water, as it should be present in the water in the PPB level and by the VG. VG is also a good technique for measuring the arsenic, selenium, mercury. Do you know mercury, arsenic, selenium should be present? If it is there in the water, they should be in the ppb level. So to measure the ppb level is not an easy task. We have to take a special instrument, special assembly to measure it. But it is necessary, it is very essential to measure them in the water. What will be happen when it will cross their limits? So beyond this limit, metal can cause adverse effect on the taste, color, and highly toxic to the human beings. So metal also impart color, as I said you in my color slide, they impart colors and they are naturally affect the taste also. And if how can we bring a water with having a metal in it, the high concentration and highly toxic? There are a lot of metals which are very toxic and from these metals they come sometimes from the natural and from the industrial waste because the deteriorating quality of the water. Microbiological analysis. I have already told we have taken care of the physical parameter, chemical parameter. Now it's the time for the microbiological parameter. Microbiological parameter, if we go for the case of a drinking water have only one parameter, NPN coliform. Because already they have so many tests in it, NPN coliform give the idea about you if the water is safe or not. But these tests which are showing on your screen, they are very mandatory for the natural mineral water and also for the packaged drinking water. Because as you know, a lot of packaged and mineral water is coming up in the market. So they have to go for all these testing. As per the BI specification, these are the mandatory tests. All tests are mandatory, but microbiology is a must. These are the tests for the mineral water and the uh, packaged drinking water. Or maybe you never know, in the coming time, they are also included in the drinking water also. So these tests are Eastern mold, test for E. coli, coliform bacteria, Pectococci, Salmonella, Shigella, Pseudomonas, Vibrio cholera, Vibrio paramycetes, Pseudomonas, Aeruginosa, sulfite-reducing bacteria, Staphylococcus aureus. So, as you are able to see my screen, then you're seeing it that they should be absent, they should not be present. Testing should be carried out and their effect, it has a lot of effect. You know, many times you have listened this, पानी पीने से वो होगा infection. पानी से ही होते हैं सारे infection. We have heard a lot about all these things and it is very true. For the chemical, we're taken care, but we have to take the microbiological analysis also. As you see, it can cause the fungal infection, diarrhea, Typhoid, no, it's the water is the carrier of typhoid. Shingolysis, diarrhea is the main which created by so many bacteria or virus. Cholera, again diarrhea, and again the bones. Sometimes now it is the latest. I have heard a lot of people has a problem for the bone stiffness and the food poisoning. Food poisoning is also carried out with with the presence of this audience. So I would like to say these are also a very important parameter to be tested for the water, and I will request BAS people to also include in the drinking water for the people benefit. Other important parameters is added are PCB, polychlorinated biphenyls, polynuclear aromatic hydrocarbons, and pesticides, radioactive residue. Radioactive residues, alpha emitter and the beta emitter. How this contamination come into the water? These are the human advancement. We can't help it. We have to be advanced. We have to progress in each and every respect. But the side effect, we have to face it. No? So the side effect is always there. When we eat any medicine, the doctor, you also ask from the doctor, will this medicine give any side effect? Sometimes doctors say yes. But nowadays the people are very smart. They search every medicine on the Google which give their side effect. But sometimes even having a side effect, we have to take it. So you have to take this. You have to test this. So that if it is present there, the remedial action can be taken. Now, this is all we have. We should all have this all parameter. We have to be tested in the drinking water as well as the packaged water and the natural mineral water. All parameters have to be taken care. This makes sure us the water is safe for the drinking purpose. Now, have you seen the standard has taken so much effort to make the water safe and clean for the drinking purpose. Now, what I have give you this in my slide about the organophysical properties of the water. It is a compilation of each and parameter in it. The method of test is there. What are the detection limit of the method? This is not the prescribed limit by the IS standard. This is the detection limit of the method. In the case of color, we can't go beyond the 5 because the standard beyond the 5 gives the colorless, the standard becomes the colorless, so we are not able to compare it. Yeah, we can go for it. We can make the standard 1 ppm, 1 into 1 Hazen unit or 2 Hazen unit and then compare with our water. If that give also a colorless, then we can say, yeah, it is colorless. Or it is the best way to go for the spectrophotometer method. The method for doing is all this, the APHs and IS 3025 part 4. I think you are all are aware of the IS specification. They give the very good method in it. Second, odor, taste, they are qualitative methods. They cannot be, they don't have any detection limit, but this not be, they are the not, they should not be present in the only we have to say it should be agreeable or the disagreeable. Taste again, taste depend upon the different people flavor. Maybe when I drink some water, I like it very sweet taste. Some drink it's a little very salty one, and some say it is a sour. Some say it's a bitter. So it depends on person to person. When we go for the taste, so we have to take a flavor rating of the taste for the. There is a batch of the people sit in the odor free, in the free atmosphere, and everybody will given the sample to taste. Again, what I have mentioned you, what you can say about, and the maximum rating given to that things, you can have that, you can go for the test, that flavor of the test. If supposingly there the 10 people are sitting in the back in the group and 8 people give, yeah, it is a tasteless, then we say it is a tasteless fit for the drinking purpose. And the 9, it was the 6 people say no, no, it is so. Then when then we will see it is not agreeable with the taste and we disagree. Same with the pH, it is electrometric method, which ranges from 1 to 14. And the turbidimeter, I already described the electrometer, the specifications are IS 3025 part 10, boron is the colorimetric and the ICP method. Barium is also carried out by all these things by the instrumental analysis. Calcium and magnesium, calcium can be done by the EDTA titration, also by the instrument. But what I prefer, the titrametric method are more fun and I think the calcium in the drinking water. Chloramine, this is also added by the to avoid the one thing I am really totally forget to tell you. Nowadays there is a problem with trihalomethane. How the trihalomethane is formed? When the chlorine is present in the water, then what happens? An organic matter is not there. Then they form the trihalomethanes, chloramines. They are sorry, chloramine are there which are made with the help of chlorine and the ammonia present in the water. Basically, they are not very dangerous to the human person, but it should be in the less quantity. Chloride, copper, I have already described you, manganese, mineral oil, nitrate, alkalinity, sulfide, sulfate, silver, phenol, selenium, and hardness, zinc, uranium. Uranium is again the radioactive. It is recently added in the drinking water testing. Maybe again I said because of the radiation emission with a lot of things which impart their effect on the drinking water. And now the polychlorinated biphenyls and polyaromatic hydrocarbons that has to be do. Just look at the figure. They should be if they should not be present if their detection limit of this method is, you can say 0.5 ppb and 0.1 ppb. So basically it should not be there. The method were carried out with the ASM and EPA, but we have taken care of all this using the GCMS in the most sophisticated instrument. So nowadays the laboratory should be built up to have a more sophisticated instrument to carry out the analysis in the early possible time. The trihalo method which I am talking about, trihalomethanes are made by the chlorine with the organic matter or with the organic solvent to be discharged in the water with the by the industries. They are also not good, and the detection limit carried out from the method is 0.01 ppm. Pesticide is also very important point. In the initial of my presentation, I said lot of pesticide and insecticide are discharging in the water without any treatment. Halaki government has taken a care of it. They instructed the industry to not to discharge as such all their waste in the river or lake. But who will keep the eye on them? And even the government makes the strict rules to get your water tested. Yeah, it is getting tested, but can I ask one question? Are the water given for the testing are really the same water which are discharging in the river or lake? As far as my experience coming, sometimes it's no. So the laboratory which carrying out the analysis, they should collect the proper sample. Then we can have a proper result with it. Pesticide residues are so many have to be tested. that is a chlorine-based pesticide, phosphorus-based pesticide. They can be carried out with the GCMS, LCMS, and detection limit is a microgram in the ppb, that is a 0.01 ppb, as well as the standard says it should not be there in it, and the method, as per the method in the USP, it should be carried out. Now the radioactive substance, the bacteriological quality. Radioactive substance, I have already told you alpha and the beta emitter. How to carry it out? Method of tests are the gross alpha counting or the beta gross counting. Detection limit is also limited for this. They can be the 0.04 and 0.45 their unit. The method of testing is prescribed in the IS. Now the bacteriological quality of the drinking water. These results are given in the 100 ml. It is tell in the CH. So in the case of a E. coli or the thermotolerant bacteria or total coliform bacteria, the method is the membrane filtration techniques. The limit of this method is 1 CFU per 100 ml. And we can follow the specification of this IS 15185 given by the BIS standard. So at the end, I can say water quality testing report should be delivered. The person, the analyst, the laboratory which are testing the sample should deliver their testing report shall deliver the reliable results, dependable and defensible result. What do you mean the reliable? We can rely on that, yeah. Reliability can be done by repeating it. If a person say I am not satisfied with the result, then this can be shown. Yes, it is there. We depend on the result because of their having a sophisticated instrument, trained analysts, and the result should be defensible. If I am giving the testing report of some result, so I should defend the result. Why it is so? Why it is like this? Here, I conclude my presentation with this, but for the IS and BIS, but now I will go for my second presentation, which impart the IS 1055 limit for the drinking purpose. Let's have a look. It won't take a much time. Will you please excuse me for a minute, please? Now, I would like to share some of the limits as per the BIS standard. According to that, the water is getting tested. Drinking water, because as a drinking water is intended for the human consumption, with the human consent we use for the cooking purpose, also cooking. Naturally, the water which is coming in our tap is used for the drinking purpose, for the cooking purpose also. So in this specification, it is given the acceptable limit and the permissible limit in the absence of the alternate sources. Alternative sources described as if supposedly we have a water, we do not have a permissible limit, but it can be extended in the absence of, it can be go to the different limit in the absence of alternate. When we don't have an alternate source, we don't have a treated water, the water which is available with us, we can also carry out our requirement We can do our requirement with that water also. Requirements of the IS is the organoleptic and the physical property, which I have already explained. Parameter containing the toxic substance, parameter containing the radioactive substance, bacteriological quality of the drinking water, a virological requirement. The virological requirement is a very difficult because it's needs a different instrument. Now the laboratory is going for that also. So now I will like to give you parameter-wise maximum limit and the permissible limit and their impact also. Some I have already told you, but now a quick recap of all this thing. Now the first parameter, what we have taken, the color. The maximum limit of the color is 5, but it is in the Hazen unit, but it can be extended to the 15 in the absence of alternate sources. What will be the impact in case of values are beyond the limit, beyond the limit, permissible, beyond the permissible limit? Now, in the case of color, odor, taste, we have a aesthetically unacceptable. It is aesthetically unacceptable, which I have already explained in my previous slide. Now for the pH, for the odor and the taste, it should be agreeable. It should not be disagreeable, because disagreeable is not it's not a choice for us. pH value, pH limit by the IS is 6.5 to 8.5. Well, below the 6.5, it is not acceptable, and above the 8.5, it is also not acceptable. I think for this I have already told you. It renders the acidity and alkalinity and also affect the distribution system. And the turbidity limit, maximum limit is 5, but in the absence of alternate, if we can go up to the 5. The impact is again aesthetically unacceptable. Naturally, we have already discussed why we should drink the turbid water. Total dissolved solid is also an important one. The maximum limit as per IS is 500, and in the absence of alternate sources, it can go up to the 2000 milligram per liter. Its effect is organoleptic implication. Now, the parameter of the aluminium, it is 0.03. Permissible limit is 0.2. It causes this cumulative effect reported in the case to the cause dementia. So you look at this. Metals should not be present. If they are present, they should be present in a very, very low quantity, because we cannot avoid due to the pollution of the deteriorating quality of the water. Sometimes it is there in the water, but it gives a serious effect. It's really cause dementia. Ammonia, maximum limit 0.5, and they don't have any standing limit, not excessive. It indicates the pollution indicator. When I have already explained you, ammonia is a sign of pollution. From where this pollution comes? Sometimes they're mixing over sewage. Sewage is full of ammonia, so they cause it. Anionic detergent, maximum limit 0.2, can be extended in the absence of alternate sources. The permissible limit is 1. Pollution indicator, irritant, cause froth, barium, maximum limit 0.7, but they don't have any permissible limit. It cannot be extended. Beyond that limit, it is unacceptable. For boron, 0.5 is the maximum, but it can have a limit for the 2.4. But you cannot go for the 2.4, because for going for the 2.4, it gives the neurological problem. Boron should not be there in the water. If it is there, it should not be more than 0.5. But you don't have any choice, then you should go for 2.3, not more than that. Calcium, maximum limit 75, permissible limit 200. What it's got? It's got hardness and the scaling. Chloramine is about 4.0 milligram per liter, but It should not be relaxed beyond that. As a toxic, it is toxic, taste is get affected. Same with the free residual fluoride, sorry. Fluoride should be present, have a maximum, but it is there, as it is natural occurring element, so it is there. It should not be, maximum limit is 1.0 and permissible limit is 1.5. Beyond that, it calls the chlorosis. Beyond that, it calls the chlorosis. Free residual chlorine. It is the test is only when the water is chlorinated during the treatment. Chlorine is added to the water. The maximum is 0.2 and it can be allowed 1. Taste affected with the higher concentration. Same the metal, iron, manganese, they have a different effects on the body. Sulfate, that is also a natural occurring element. So it will be there. So it can be have a 200 maximum limit, but can be extended to the 400. Beyond that limit, the gastrointestinal irritation. If magnesium and sodium is also present with this. Sulfide toxicity is there and unacceptable odor. Alkalinity, it should be there because it is a neutralizing capacity H ion or H plus ion. The maximum limit is 200, but we can go up to the 600. Beyond this, it is have an unpleasant taste. Same with the hardness. The limit is 2 and extended to the 600. What happened? If the hardness is there and construction of the supply system, the salt will be deposited on this and the taste is also get affected. Zinc, cadmium, it also affect on the taste and the transparency of the water. Cadmium is very toxic. Cyanide is also very toxic and also reactive also. Lead is toxic, bioaccumulative, mercury, molybdenum, nickel. Every metal present is a very toxic and highly effective to the body. Nickel, allergic on the high, it gives the allergy on the high exposure. Arsenic, and total chromium, they are also, even if we see all the metal are toxic and bioaccumulative. Now the polychlorinated based by biphenyls and the polynuclear aromatic hydrocarbons. They are also toxic. This I already explained you, bioaccumulative, persistent, hazardous, and all. Where trihalomethane, it is potentially carcinogenic to the human being. And for the pesticides, they are toxic and the bioaccumulative persist. Well, for the alpha emitter and the beta emitter. Risk due to the radionuclide upon the exposure and the concentration. E. coli bacterial contamination lead to a short-term waterborne disease. It is there for short-term if it is increased in the limits. So, thank you everyone. With this, I conclude my presentation.
Thank you very much, ma'am, for your brief and interesting presentation. Certainly, it was very good to understand the
Let me
standard
conclude
as well
this,
as.
sorry. Yeah, let me conclude in one sentence, please, if it is possible for you.
Please, please.
With this, I conclude my presentation and hoping to make everyone understand the importance of the safe drinking water with respect to its quality standards.
Yes, ma'am.
As one thing for the show, water is safe drinking water is for the health and which is ultimately the well-being of society. So I request all of you to let's join hands together to provide the safe drinking water to every single life, so that we should not end up by saying Water, water everywhere, but not a single drop to drink. So I would like to thank everyone for your valuable time. Last but not the least, I would like to thank the organization to give me this opportunity to present myself in front of you. Thank you so much.
Thank you very much, ma'am. Thank you for
Thank
your
you.
brief and interesting presentation. We are really thankful to you. You have made this exercise very well. Now, I think we have few questions. If you kindly allow, we can raise, if we take few of the questions. Somebody has asked that nitrate is not essential. Is it okay?
Well, it is given there. It is, but why it is in then? When I'll ask one question, then why it is in the testing parameter? Why the BI added to in their testing parameter? I know it's a huge limit in that. It is something important in the water. That's why it is there in the testing. So this is what I have to say in all this.
Okay.
Second.
Good. Second is, ma'am, what is the present of safe drinking water in India? Which water, RO or distilled or natural water is safe for drinking?
Again, natural mineral water is automatically safe. We are using a RO to remove the contaminant, but RO also have a very side effect. Nowadays, RO has improved their quality. They have put the TDS meter in it because they used to remove the 90% of the salt in it. Our body also needs a salt. If there will be no salt in the body, what will do? Our body work as an osmosis. Our body take out all the metal, important nutrient present in the water will come out from our body.
Thank you, ma'am. The next is.
Sorry, ma'am, आपको mic mute है.
Now, I would like to request all the participants to kindly switch off their mic and switch on their videos so that we can take the photographs of all the participants for placing it on our Twitter handle, Facebook handle, and Instagram. I'd like to request all the participants to kindly switch off their mic and switch on their video, please. Thank you. Now, ma'am, another question is, yeah, there are a large number of questions. I just take one by one. In the meantime, my NIC officers will put all the participants on.
I'm ready. I may not be able to answer all the questions, but I try my level best to answer the questions as much as possible.
Sure. Thank you. And we will share your presentation also, ma'am, in the groups and with the Santoshi, kindly share the presentation with the certificates today. When you are issuing the certificates to the participants, we have large number of participants today. Yeah. So please.
Okay.
And with the certificates, you kindly share the presentation.
Shobhaji.
Yes,
Shobhaji, good afternoon.
Dixit sir, would you like to say something?
Yeah, this is Maruti Prasad, sir. This is Maruti Prasad from Hyderabad. I'm a retired scientist from the Central Groundwater Board. So, yeah, we have participated in many meetings of the BAS. The inclusion of the nitrate never be as a essential element or something. It is one of the utmost delicate parameter for the kids, particularly. And many people may not understand what is meant by the blue baby syndrome also. It is a very clearly mentioned in the write-up. Very clearly we have given it. And also it is not at all essential nitrate. Nitrate is a toxic one.
It is toxic.
That's one reason. That's one reason.
I will ask the same question.
That's one reason we have removed from the. That's the reason we have removed the permissible limit at all. We said it is acceptable limit, but it is not essential. It is not at all essential. It is acceptable to that limit. It is toxic. It is something like cyanide. Every parameter has got a limit, but cyanide doesn't require in all the parameters way. Okay? At the same time,
I won't repeat my mistake as you say it is not an essential parameter.
And number one. Number two, fluoride. Coming to the fluoride. Fluoride, it has got the dental fluorosis and also skeletal fluorosis. Nowadays, fluorosis into the multiple ways. I'll tell you a very small example. We are talking much about the water and water products and all those things. If you take a roadside food like gupchup, we all will accept gupchup is one of the famous product in India, where we are intentionally feeding the fluoride to the people. That too, to the extent of few hundreds of ppms.
I know fluoride is a very like toxic parameter also, because I have done the work on the fluoride removal project
fluoride
in
is
the
essential.
Bihar and in the Rajasthan also.
Yeah, fluoride is essential to some extent. At the same time, it is very delicate.
Yeah, initially, if you are aware of it, BI specification, make it the essential parameter for analysis.
Yeah, that's one reason. That's one reason we kept them in the limitation levels.
Yeah, I agree with that.
Yeah, and coming to the you requested for the inclusion of the various microbial parameters, which is not possible in anywhere analytical laboratories in the India. We know pretty well the limitations are standard.
I know. Can I interrupt you? As you said, I do agree with you. But all the laboratories are testing the packaged drinking water, the bottle, natural mineral water. That means they have a facilities, no? They do have a facility.
So that is see, that comes under the sales. So when people are selling it, they have to do all those parameters. But when coming to the supply water, what we are giving, the thermotolerant bacteria microbe itself is the best indicator. So that's one reason we kept only the.
Can be included. Not all. Some of the parameters should be included.
Can't be. Initially,
Dy.Dir is a major for the jaundice.
Yeah, madam. Initially we have included. Of late we have realized that thermotolerant is absent means remaining things also absent. So keeping that point in the mind, we have removed it.
Okay, I'm happy to hear the
Yeah, that's right.
Now,
Thank you, ma'am. Thank you, ma'am.
Thank you, sir. Thank you for imparting your knowledge.
Thank you very much.
Thank you.
Ma'am, thank you so much.
Thank you very much.
Yes. May I know any other question? No, I'm not able to hear you.
My request to all the participants to kindly share the questions in WhatsApp or the mail so that we can reply, because if many people are speaking at the same time, it will be very difficult.
I will really happy if you get the.
So, and I would like
to all the questions. I will definitely reply.
Good. Mr. Chandrasekhar has written that virus detection methods are available now.
Yeah.
Very good information. Yeah. Thank you.
Yes, and I know what you are saying.
Virus issue.
But it's this parameter is not recently, a few years back, is added to the specification. The laboratories are not prepared to add the special technique, the special facility for the virology. But now it's an essential parameter. It's important, so they have added it in. I think most of the laboratories are going to add it in their testing report. I hope I satisfied your queries. I'm not saying that the not doing it, but they are trying to do it.
Santoshi, is it done?
Yes, sir.
I agree to him. I'm not denying that. So, anything I can do for you people? You all are the learned and intelligent ones, so it also helped me to impart my knowledge, increase my knowledge with everyone. It is a good, I'm happy, really happy to have it. So I think I should go from this presentation now. Everyone is done. Ashutosh, I'm not able to hear you.
I would like to thank all the participants for participating in this workshop. I'd like to thank Ms. Shubha Kumar, who has given this nice presentation, and all the participants who have enlightened us with the new information.
Right.
Now we will meet in the next week. With this, I would like to close with thanks to all the participants this today's workshop. Thank you very much.
Thanks to everyone. Thanks.
Thank you, ma'am.